I got a little joke. You want to hear about this little joke?
Yes.
Okay. All right. Let's see. Now, don't laugh till I get to the punchline, okay? Because it should be. It's gonna be funny. Why can't you trust trees? Why can't you trust trees? Because they're shady. High five, high five. Hey. Okay, don't let me hang. You're so sweet. Okay, so for this little experiment, which is the enthalpy of reaction between baking soda, unlabeled in this container, and acetic acid, which we'll use as vinegar, labeled in this container. Again, this is just simple calorimetry, but we'll see what sorts of results we get. Hard to find this value online as well, but it's definitely one that I get general information on about. So our first thing is to get our surroundings set up, which I have right here in the graduated cylinder. I made a 50-50 mixture of water and vinegar solution. And we have a total of 100 mils. Okay, so that's a dilute solution of vinegar. So we can assume that to be just water when it comes to calorimetry. Really, our limiting reagent is going to be here in the baking soda, so I'm going to use a small amount of that, and we'll use the mass by difference technique. Here's our weighing boat, this little medicine cup, and I'll show you these measurements as we go through. So the mass of my weighing boat, which is this medicine cup, empty, is 2.70 grams. I'm going to pour in my 100 mils of vinegar water solution and get the initial temperature. Very important. We'll let that sit for a few minutes and then get a reading. I've got her vinegar baking soda reaction going. I'm going to get mine going here now.
It's really annoying.
Okay, so I'm going to tap that in. You can hear it. Okay. Now I'm going to stir it up. Very important to get this all reacted away. Once it's all reacted, we can then look at our thermometer, see what happened to the temperature. Did it go up? Did it go down?
And I got my thermometer.
Okay, all right. Looks like we're near completion. Okay. The thermometer's dancing around a bit there. Not bad, not bad. Okay, Nora, looks pretty good, eh? You don't see any baking soda left in there, do you?
So,
okay, I'll leave that in
I
there.
got to get that in
Temperature.
there. Is it a solid?
Down to about 22.8, I'll say. 22.8. I'll check again. So 22.8 was the lowest temperature reached, so the water temperature went down in this reaction. Therefore, the reaction between baking soda and vinegar must be endothermic. It's taking heat to do it. Surprise, surprise. The online source did say it was endothermic, so our only other task now is to work this into an enthalpy value using first law. Okay, so from the mass by difference technique, and then we got all the baking soda out. You can clearly see it in there. So the final mass is 2.75. I'll subtract that from my mass that I had initially, or not initially, but just then. Okay, so the 2.75 grams I just got had to be subtracted from the 3.40, which was the mass, the previous mass. So that really meant I transferred and reacted 0.65 grams of baking soda with the excess vinegar solution, okay? Now, Bear's here as well, and Nora, and Sylvie, they're around, but just to put all the calculations together, excuse me, Nora. Oh, whoop, careful. So the number of moles, and most importantly of the baking soda, our limiting reagent is worked out here, okay, from the mass and molar mass. You can see it there, it's a fairly small value. We need that, of course, to divide through both sides by that number of mole. Delta T has already been worked out, so I'll put it in the first law. We end up with Q of the reaction is going to be related to the negative Q, or the heat of the surroundings. Again, with the details put in, we got our N delta H equals negative MC delta T. Then we need to divide through by N of the baking soda, our limiting reagent. So here's all the values from up above in their appropriate places in the rearranged first law to solve for the enthalpy of this reaction, molar enthalpy of this reaction, respecting, of course, baking soda. So when you get it, you get two negatives that multiply, so they cancel each other out, and you end up with 37.9 kilojoules per mole. So that comes out in joules per mole. We divide that by 1,000, and you get a positive 37.9 kilojoules per mole. So in terms of the overall reaction, baking soda combines with vinegar or acetic acid to produce CO2, water, and sodium acetate. But since that number of kilojoules of heat are required, that ends up showing up on the reactant side. Okay, so here's the final formula, thermodynamic balance equation with the heat term on the reactant side. And that's the enthalpy. And that's the final result. Put this in. It's cold. Put it in the water. What's going on?
Orange peel.
Is it getting cold?
Yes.
What is it, ice?
It's so cold.
It is cold.
Oh, what's that?
That's a scupula.
What a super
A scupula is for making things go in the containers. It's like a spoon, but for chemistry.
That's not right.
Well, don't touch it. It's cold. It's melting.
Yes.
Nice.
No.
That's.
I put that in there.
You can, but this is Nora's lab. We better be careful. Fun?
It makes happy.
Beautiful. Uh-oh.